Ladies and gentlemen, once again, our host, Jeff Perkinson.
Thank you so much, and thank you for coming back after last night. Everybody have a great time last night? Yes? Was that the chamber orchestra was fantastic. It was quite unexpected. I walked in and looked at the room, was beautiful, and then the music started. And the room just got like 3 times as beautiful. It was amazing. I hope all of you had the same experience and had a great time. There were lots of conversations that I heard taking place, lots of good talk. I heard lots of discussions of innovations and improvements that were happening at businesses all over the world, the places where you live and work, and we very much appreciate that. But by the way, that building was once the King's Court. It was also the site of the Declaration of Independence here. So it is quite the building to be in, and I hope all of you had a lot of fun also. If you were inspired by anybody that you met last night, or anybody you've met at the conference, and you want to continue those conversations and those relationships, the best place to do it is in the JMP user community. If I could ask for a show of hands, who has visited the JMP user community thus far? Excellent. All right. Now, all of you who have your hands down, whoops, wait, keep those hands up. All of you who have your hands down, look around and imagine all of those people that you've missed meeting thus far. Now you can put your hands down, right? So all of those folks have already figured out the great resources that are available in the JMP user community. There is a discussion forum. I had somebody was talking yesterday. They said they had a question and they were like, I don't know, where should I go? And they said, I'll go look at the forum. They searched, they couldn't find the answer. They posted the question, and I believe the comment was within about an hour they had gotten the answer to the question. So the discussion forum is full of people from around the world who are chomping at the bit to help to answer your question. We are there, our staff is there. And then there are users literally from around the world. So please take advantage of the discussions forum. You'll also find the file exchange where our staff and others from around the world have posted extensions to JMP, add-ins to make JMP do things that we never even thought of it doing. Perhaps you've got one of those and you would like to share it. We would love for you to share that in the file exchange as well. There's some sample data there. There's also scripts, lots of good resources there. And of course, as I said yesterday, the user groups from around the world are also there. So if you want to find a regional user group and join that group and stay in touch with what they're doing in your area, that is the place to do it. So speaking of sharing things, if you are tweeting or sharing on Facebook or LinkedIn, please again, remember to use the hashtag JMP Discovery Summit. There were some great tweets from yesterday, and we have featured some of those in the app. You probably have seen them. So please use the hashtag and let us know what you think of the conference that way. Your colleagues back home can still follow us at jmp.com/live. Our bloggers are back here ready to start blogging our plenary talk this morning. If you've got colleagues who aren't here and they want to follow along, they can do that at jmp.com/live. Now, we do have to every year say goodbye to some of our steering committee members, and for that we are sad that we have to let you go, but we do have a couple of new members joining us. If I could ask Jean and Kevin to stand wherever you are in the room. There's Kevin and here's Jean. They will be joining the steering committee for the next couple of years. They will be helping us guide and plan the conference, so please give them a round of applause. Welcome them to the... Thank you. Thank you very much. As you see them through the course of the day, give them your feedback. They will be helping us, and we appreciate it. Don't forget today, speaking of feedback, to please rate the sessions. I know that you've heard this a bunch of times, but I do want to remind you, we will be giving away awards after the last plenary today for the best papers and poster, and that is, again, based on your feedback, so please do use that button to rate the sessions. Now, our next speaker, Ron Kennett, is a professor at the University of Turin. Now, I don't know how many of you have been to Turin, but you don't get hazardous duty pay for working in Turin. This is what it looks like. I know that's a difficult assignment, Ron. We appreciate you taking it on and having to work in that beautiful environment. In all seriousness, Ron is a professor in the mathematics department who certainly believes in the power of data-driven decisions, and he's had many famous statisticians as teachers and role models, and he's going to tell us some stories about them. He will also explain his framework for information quality that he developed with yesterday's keynote speaker, Galit Shmueli. And he does want to put stats back in the driver's seat, so here, to give us that tour, please welcome Ron Kennett.
The fishbowl? We're going to talk about that. Okay. Thank you. Okay, good morning. I don't see anyone, so I can ignore you. So the elevator pitch, you know, the 1 minute. I think this is quite a unique conference, and the reason is that using Galit's planets images yesterday, you can imagine the planets, the 3 planets she showed. Where is Galit? Oh, okay, hi. I think there are 3 planets that need to meet. One is the practitioners, the applied statistics planet. The second is the academic planet, the research-oriented theory development type planet. And the third one is the delivery planet. Okay, in 2017, if you publish a paper in statistics and you don't provide some code to implement the theory, you have not delivered. So I think that what you see here is a fantastic combination of these 3. Monday, I heard Brad present his latest technometrics paper in a very accessible way. I had looked at the paper, but I didn't really get all the insights that I got from listening to him. Yesterday, Kevin, with good Irish humor, presented what Intel is doing from the practitioner's side. And the touching thing was this seemed to be like a personal initiative to fulfill some kind of vision which has analytics included in it. And John yesterday gave a fantastic presentation, very meticulously prepared on how the delivery platform can make this happen. So this combination of things is really quite unique. I don't think you find this in many conferences. So I'm going to take you on a journey which, as Jeff was mentioning, is starting with my role models, not so that you understand where I'm coming from, in a sense. And I'm going to end with what I've considered challenges for quite a few years. And actually, this meeting that I mentioned before between these 3 planets is really one of the biggest challenges facing today. And since the demand for analytics is growing, if you're able to do that, I think there's really huge potential. You know, you usually say these things, but I really believe that this is the case in 2017. So I'm going to have 3 stops. The pace will not be uniform. And some of the points I'm going to make are only going to be made very briefly. Following this talk, I will be glad to provide more details if anyone is interested. So, role models. I'm going to talk about the person who taught me Statistics 101, I'm going to talk about my PhD thesis supervisor and 3 people that I've met after I finished my PhD. So when I joined Imperial College as an undergraduate student in the old Huxley building, which is part of the Victoria and Albert Museum now. So you can imagine the setting almost like the room we had yesterday. I was registered under mathematics, and the mathematics head, the professor, and the English style makes the professor really someone way above everyone else, was David Cox, and he was teaching Statistics 101. Okay, I later called this the Cox model of education. Actually, I've never seen this happen again. I mean, this was a unique experience. And just to give you a flavor of what this course was about, that's what motivated me to get into statistics. It was about fine work in statistics. And this is just a sense of what this was about. It involves minimal mathematics. That was the opinion of David Cox in 1981. He still has this opinion. Some bad work in statistics gets by because of its apparent mathematical content. So we are not talking about mathematics and mathematical sophistication. After finishing my undergraduate studies, I went to Stanford because my supervisor was at Stanford at the time. Eventually, the idea was that he moved to Israel, but this never happened. So I finished at the Weizmann Institute, but I spent a lot of time at Stanford. And this guy, Sam Carlin, was a really genius in mathematics. I don't know if you can see, he is over here. I am over here. And if you go up, you see all the names that you're familiar with. So Felix Klein, Gauss, Euler, Bernoulli, I mean, this is it, right? The claim to fame of Sam Carlin, who had Fisher as his role model, was something called BLAST, which really does not involve very sophisticated mathematics. How many of you have heard of BLAST? Okay, thank you. This is what helped the Genome Project actually happen. Okay, it's DNA mapping, and this is a very, very important contribution from the practical point of view. Actually, Sam Carlin went into writing papers on molecular genetics and things like that, even though he came from mathematics. Then, after my PhD, I was in medicine for 2 winters. I mean, I would say 2 years, but the reality is 2 winters. The winters, they are long. I don't know if you know what cabin fever is, but it's really it's a terrible disease. And my next door, I got an office, and the office next to me was Bill Hunter, and Box was not department head, but very prominent figure, and these people sort of made it look different. In other words, what is statistics now started to take a different shape. The issue of problems, okay, that I also had before. The need for continuous investments in learning environment. I don't know if anyone has seen Box play with the slides. Oh, he was a master at that. Yeah, he's well, it's funny now to think about this, right? People would do this. I mean, this is the fact that fun should be part of doing and learning statistics. I don't think Cox was talking about fun when he was mentioning statistics, but these guys, oh, that was really essential. And eventually, the need for interactions. Okay, the Monday night beer seminar at Boxer's house where people were drinking beer and there was someone coming, an engineer or a biologist, and then Box or someone else would address the question. That was an interaction with other disciplines. And I was very fortunate to attend this. So here you have Box, Hunter, and Hunter, BH Square, singing along when their book in 1978 came out. How many of you have this book? Fantastic. Okay, so this was a very influential book. Bill Hunter was in the middle in the authors list. He got pushed to the 3rd place in the 2nd edition. And in the preface of the 1st edition, I think the 1st edition is actually better than the 2nd one, because some chapters that were in the 1st edition got omitted. You find this. Okay, calculus does not appear in the main body of the text and is not needed to understand and use the book. Even more important than learning about statistical techniques is the development of what might be called capability for statistical thinking. So here is Stu Hunter last year. So when I try to define what it is that I'm doing, this is the definition. Okay, I'm working in an area called applied statistics, which is about solving real problems with mathematical tools and statistical thinking. The real problems we understand, the mathematical tools we have, the statistical thinking is an abstraction. Okay, and the methodology for enhancing statistical thinking, developing statistical thinking, I think is still lacking. And it can only come from this meeting of the 3 planets I was referring to. People have written about that, but I think there's really much, much more to be done, especially with this growing demand for analytics. One of the things is to support a life cycle view of statistics or analytics. By life cycle view, I mean you start with something that is called an unstructured problem. Okay, you talk to your formulation experts, your chemists, your engineers, and you have to translate their concerns, their interests, into an analytics language. And that takes some experience. There are not too many methods for doing that. Okay, the way it's taught is spend a few months in the statistics lab and see how it's done. So it's apprenticeship. And then you go through this life cycle, and it should end with some impact assessment. And I'm going to talk about InfoQ, which is coming from this type of perspective. Do we have quality in the information we generate from a life cycle view? Academic courses, and I've taught these courses, and believe me, I'm not very proud of that, are focusing on a piece of the story. And that's the problem. You know, once they give you the data and they say, apply a regression on this set, you miss the whole story. I mean, and the assumption is that when you're going to meet the need, you will know what to do. And that assumption is fake. It's a fake assumption. You have fake data and you have fake assumptions. It doesn't work. So something has to be done in how to educate people. And one of the things is to get their data, the things they're working on, used in the education process. And the people from Intel were saying exactly that. People come with their data. It's numbers, right? It's going to be 12, 15, 16, but it's their data. And data is different from numbers because data have a context. So in the progression, you have numbers and then you have data. The difference is that you've added a context. And on this life cycle view, you've made great progress. So with this general background, I was director of statistical methods for a corporation, a telecom corporation. This came out because I somehow convinced the CEO to attend a Deming seminar. And he came back and said, we need a director of statistical methods. You're going to be the director of statistical methods. One of the things that Deming and Juran have talked about is how do you manage organizations. And in general, there are 4 types of management approaches. You have the firefighting, very common. Then you have those that are fed up with problems. They say, we're going to induce inspection. Everything is going to be inspected. Okay? We're not going to let anything go out the plant without inspection. Then you have the ones who realize, let's look at how we do things, not the results. And then they start focusing on process improvement. And then you have those that say, actually, what we do, what we experience, is a result of how we design things. So that leads to what is called quality by design. And the book I have with Shelley Sachs, this is the second edition. The first edition, Kurt was the editor. I don't know where he is, but I was really pleased to see him. He's not here. Oh, he is, okay. So that book really had an impact on my career. I don't know if you realize that, but it was when I was at SUNY Binghamton, and Kurt was the editor for Wadsworth Belmont. So the book starts with a chapter that talks about this. Okay, it's the book on industrial statistics. If you really want people to use the statistical methods that are part of this arsenal of tools in industrial statistics, you also have to be concerned with the management approach. If you're going to talk about control charts in an organization where management is firefighting, it's not going to be effective. So your job as a statistician is to get the organization higher on this quality ladder. And that's what Juran and Deming were doing. You know, they were management consultants on top of being expert statisticians. So this book in the second edition has a first part, which is principle of statistical thinking, and then acceptance sampling, process control, design of experiments, and reliability and survival. Bill Meeker is here somewhere, probably, but I don't see anyone. So this is how the book is structured, and it's with R, Minitab, and Jump. Okay, and I specifically want to be neutral in this. Okay, and I think it's very important to keep the flavor right on what I'm trying to present. It exists now, the book also in Vietnamese, and the first edition is in Spanish and Chinese. So I'm going to take you now in this journey through what is called quality by design. We had this chapter in the first edition, so for us this is something that we've talked about for quite a while. So quality by design. I'm not doing well time-wise. Okay, so I'm going to rush through a blog that we have on the Jump community, which has actually more parts than what I'm going to talk about. So I'm going to rush because I would really encourage you to look at the blog and get more details. So I'm going to use small letters, not so that you can read them, but so that you have a feeling for what's in the blog. Okay, so the idea is to give you a teaser to get you interested in looking at this. So quality by design has become a term with meaning in the pharmaceutical area, because I think that the beginning of the story comes with an incredible document called Innovation versus Stagnation. September 2004, the FDA comes up with a introspective review of their role in what is their job to secure the healthcare of the public. And the number of new molecules coming up, the costs that increase, put in question the way they actually achieve their objective. And basically they say, we are a bottleneck. We are not really meeting our objective. And that's when this idea of quality by design started. I think some people might correct me. There's also PAT that was around that, but I think this document was where things initiated. And then ICH, which is the International Commission for Harmonization, which basically includes everyone else in the world, started producing guidelines. The 3 guidelines that are sort of associated with this acronym of QBD are Q8, Q9, Q10. Q8 talks about pharmaceutical development. In the first block, we have an introduction to this. This is the wheel of Moeb Nasser, who now works for GSK, but he worked for the FDA, and he designed this, talking about process understanding and product understanding. We added the notion of clinical understanding to the landscape. And there are 2 technical elements to this view, which are the design space and the control strategy. The filing for QBD now is compulsory for generics. Oren should know about this. Where is he? I saw him before. Oh, okay. Oren is from Teva, who is the world's leading generic company. And the way this flow begins, so in that roadmap, you have to produce a design space and a control strategy. And that's where it's becoming interesting for statisticians, because you cannot do that without statistics. So you have a really nice interaction between your interest and the interest of someone else, and it's a collaborative effort. It starts with a target product profile, which helps you identify critical quality attributes. Actually, I'm going to start skipping things. The Q8 guideline talks about pharmaceutical development, just 2 quotes from it. Development section, where you file for your new drug, your generic or your new drug product, is where you present the knowledge gained through the application. 2 keywords, 2 key phrases, scientific approach and quality risk management. And that's the summary of the view that led these organizations to push for QBD. Quality cannot be tested into products, i.e. quality should be built in by design. Quality by design. Okay, we understand the concept. The question is, okay, what do we do with this? So in the design space, we introduce notions that were not present in the pharmaceutical jargon. Multidimensional combinations of product characteristics, interactions, and the regulatory relief that people get when they take this path is that changes now don't need pre-approval. So if you produce a design space and the regulator buys it, whatever happens within, they have to be notified, but you have freedom. So now they are not a bottleneck. They are out of the way of improvement. And this idea actually can be traced back. I was mentioning Box, to a paper by Box and Draper, 1959, where they talk about operability region O and region of immediate interest R. So all these ideas tend to reappear with some different flavor, maybe different emphasis. And I find it always interesting to try and trace the evolution of these ideas, because in many cases things are rediscovered, and in a sense, you know, it's not effective to redo something that has been done. It makes a lot of sense to improve and update what has been done. So what can be done with JMP in this context? So I have 5 examples. I'm really going to go fast through them, but I invite you to look at the blog to read about them. These are 3 5-page blogs, very carefully written, with David Steinberg under the, how would I say, strong editorial direction of a very opinionated editor, to remain nameless. So in the second blog, we have this product. We have 7 responses. We have 3 factors we can play with. Actually, the wider the design space, the less significant main effects and interactions, the better we are. We don't want to be restrictive. We want a lot of freedom. It's full factorial, 2 center points. We look at viscosity. If you move from left to right, you see the temperature increases viscosity. The cube gives you a visual presentation that allows you to start talking about what is, for example, the effect of temperature. When you do the analysis, you're going to get the significance of these effects. When you do the profiler, you're going to have a fantastic communication tool between the statistician, the experimenter, and management. And we can see that temperature increases viscosity, as opposed to blending time and cooling time. And because this is a profiler built on a model, when you play with the setup, if there are interactions behind it, they're going to show up. It's not just a main effect plot. When you center these factors, you are at 4708. And because there are 7 responses, the white area represents areas where you meet all the specifications. And as you can see with the little dots next to the line, when temperature goes up, viscosity goes up. When blending time goes up, nothing much happens. When temperature goes up, viscosity goes up, and here you see the curve. There's no pointer here, but you can see that. Okay, these are 2-dimensional representations. Actually, the story is much more intricate than this, and the guidelines, the ICH guidelines sort of make it look like this is the way to do it, but that's really not the whole story. And there's an open research area, I would say. How do you really represent design space properly? Okay, and I won't enter into this now, but so the third block is about fractional factorial experiments. We are talking about some nanosuspension, and we are looking for nonlinearity. We have a design with 6 center points. One of the factors is categorical. It's the stabilizer. There is a Dow-Fax and the HPMC something. And this is not really what you find in the usual textbooks, because now you have 6 center points, but you have a factor that is categorical, so now you're going to have to split. There's no center point for that, so you have to split the center points, 3 center points on one of the stabilizers, 3 center points on the other stabilizer. And there might be other ways, I'm sure there are other ways to do it, but we add a code for center point, non-center point. So now we have a variable which is center point variable 1, 0, and we test for the effect, for the significance of this variable to figure out if there is some nonlinearity. We won't be able to say where is the nonlinearity and how does it look, but we'll be able to say that something happens, okay? And if you look at one of the responses, which is the particle size after 90 minutes of milling before storage, that's one of the responses, you can see that the stabilizer has an effect on the mean samples, on the mean particle size, but also the center point variable shows there is some nonlinearity. So you would be inclined to start looking at maybe different designs or other models. Fourth block. Now, this is something I'm really, this is something I would really like to push forward, because it's hidden somewhere, and I think it is undervalued. We're going to optimize, okay? We have a model. The model, by the way, could come from existing data, not data coming from a designed experiment. They have collected data. So we can use this data to do something. The continuous move from existing data that they collected without really using custom design or anything, and experiments that work, there is a continuity. It's not like I was talking to Phil Ramsey it's the same data. I mean, it's not like, maybe they pay a little more attention when it's a design experiment, but it's not like they're going to be doing something different. So I am a strongly believer that the first interaction is show me whatever you have. You know, don't if it's not designed, that I don't really care too much. Show me whatever you have. So you can build a model. So now we start with a model. Once we have a model, we can optimize. Now, there are bad solutions down in the valley. There are optimal solutions. That's what your optimized desirability thing will do. But then if you move a little bit, you might fall off the cliff. And then you have robust solutions. Maybe not as optimal, but more robust. That's where you really want to be. So you can do this with a stochastic emulator. The guideline for generic drugs is called SUPAC. I won't enter into this. You have 8 responses, and you basically compare your generic product to the label. That's the path you follow to generate a stochastic emulator on the basis of your model. And what you're going to be doing is basically work on a space filling experiment on the model where noise was introduced in the factors. You can see how the noise is transmitted to the responses. And the stochastic emulator will look at the defect rate, the multivariate defect rate, and optimize on that. And I'm adding this comment for Brad's sake. Is this an alternative to steepest ascent or steepest descent? I would say yes. Mixture designs. Okay, this is another thing that really goes underutilized in industry. For some reason, the Chefet polynomials and are scaring people. You know, they see these things and oh no. But if you have a good delivery platform, it doesn't matter really, because you have the way to implement this without entering into the mathematics. Okay, so we're talking about a situation which is called compositional data, where you have components in what you measure that what you're really interested in is the relative proportion as opposed to the absolute value. So in formulation, this is the case. Okay, you're doing formulation at this level or this level or this level. What you want to figure out is the relative effect of the components. Because you're talking about relative effects, you lose one dimension. Once you know k-1 values, the k1 is known. So you are in a constrained space called a simplex or a triad diagram. You have that in the graph display options. Okay, you can represent this constraint. For example, the point here has on the second component 10%, on the first 10%, on the third one 80%. You read it off the sides of this simplex okay, that extends to more dimensions. Now, in JMP, if you indicate that these components are mixtures, when you set the profiler and you move one of the elements of the mixture, it will know that it is a mixture, and it will also change the other ones in proportion. So this is a profiler that accounts for the fact that you have mixture. And the optimization and everything else, I think I think 13 is doing it better than 12. Is allowing you to optimize in this constrained space. Okay, then you have, I will skip this, sorry. I have 15 minutes, right? 17? A half hour, okay. Okay. So we don't count your time. Okay, another thing that is really prominent. You know, once you think about this, then you see it everywhere. Okay, experiments are done with a split plot constraint. In other words, people do experiments in a way that is convenient for them to do. So they're going to put all the batches, and they're going to set up the formulation, and they are not going to randomize the different combinations. They're going to use things that are for convenience. In the clinical understanding part that I mentioned under QBD, we had this customer who was doing experiments on pigs, and on the pig back, they were trying different combinations of this thing that I'm not supposed to mention, and the timing of how long they let this thing, and and then the antibiotic, it's not really antibiotics, but was given to the pig, affecting everything. You cannot really combine the antibiotic with so there is some constraint in how you run the experiment. And what you get here, I'm going to do some advertisement, is for a few $1,000s what a product that costs 10 times as much or maybe more than that is going to do for you. So you have an ability with restricted maximum likelihood to account for the two variabilities that come from assigning what antibiotic to what pig. That's one assignment. And what treatment to what location on the back of the pig. And now I'm going to start talking about the interesting things. So I have half an hour, like 25 minutes. Okay. So we're going to do these experiments. Okay, this is a strategy that a lot of people follow. We have a knowledge building phase and we have a confidence building phase, and we're doing experiments. We're coming up with results, and now comes the question: are your results reproducible? You did the experiments in lab A, and now the pilot plant or lab B is going to try and do it. Are they going to come up with the same answers? Well, the answer is sometimes yes, sometimes no. This issue is really discussed now with a lot of emotions in the literature. And with Galit, we started thinking about this, and now I also have a way to implement that. So I'm going to give you a brief. So there is a lot of discussions on what is called reproducible research. Ursula was mentioning this yesterday too. So how science goes wrong, the trouble with replication, and now you see some terms being floated around: replication, reproducibility, repeatability. Okay. What do they mean? A manifesto for reproducible science. What they meant here is, if we redid the experiment, are we going to come up with the same answers? Okay, in an article with Galit, we clarified the terms, and this manifesto, very important document by the way, should have been titled A Manifesto for Replicable Science. So there's a terminology issue. Obviously, if the terminology is ambiguous, the discussion is cacophonic, right? The nice example, recent example of a Nobel winner on behavioral economics that wrote a fantastic book, really recommended, Thinking Fast and Slow, was that in his book, he's talking about priming experiments, where when you say something, it affects the next thing you're going to be doing. Okay, so you can prime the response. If I ask you for a word starting with N, and before that I said doctor, you're going to say nurse. Okay, that's priming. These experiments were not reproducible. And there is a lot of reasons for that, and people talk about this. One of them is that they were underpowered. And Kahneman was gentleman enough to say, yes, I included this in my book, and I regret it. Now, the guy who for me solved the riddle and made some sense is a guy from Canada, Chris Drummond. He wrote this. Okay, that's the key to what I'm going to say. Reproducibility requires changes. Reproducibility requires changes. Replicability avoids them. A critical point of reproducing an experimental result is that irrelevant things are intentionally not replicated. One might say one should replicate the result, not the experiment. The result meaning the qualitative finding. If I increase temperature, will viscosity increase? That's the result, not the number in the regression. Okay, and that's a very important concept. There is a group which has adopted this, not because they talk to me, but that's what they practice. It's Arno Wurbel from Switzerland, who worked with Kummert from Dortmund. I don't see where Ursula is, but we talked about this a little bit. And they work in animal behavior. This group, they work in animal behavior. Okay, what you do with animals, mice, you have different types of mice. You throw them into a bucket, and you look at your watch. How long will it take for them to drown? And it can be even more painful because they hang them by the tail, and they see how, I don't want to tell you what they do with them. And then they make some measurement, okay, of time or whatever, and they say, this gene or this treatment has a significant effect on whatever, okay? So what this group is doing, they don't do measurement. They do experiments to evaluate the situation in different conditions, the age of the mice, the cage enrichment. Okay, so they understand that if they change things, they will get something that can be reproducible. The story in this is that people in animal behavior are publishing conflicting results. Lab A did an experiment, they find this. Lab B is publishing the same type of experiments, and they found the complete opposite. Total confusion. So the idea is, don't give me the significance, don't give me the estimate of give me the qualitative finding. That's the claim for reproducibility. So you already saw the lower puzzle, which talks about 4 components in InfoQ. We also deconstructed this idea of InfoQ into 8 dimensions. The 6th InfoQ dimension is called generalizability. You've done a study in a certain context. You've looked at process A in your fab, and now you have also process B, C, D. They are not exactly the same, but are the results generalizable? Can you take what you learned from process A in Kiryat Gat and apply it to process B in somewhere else? Okay, is it generalizable? Okay, that's a very important question. So that's what generalizability is about. And we identified 2 types of generalizability: the statistical generalizability and the scientific or first principle generalizability. Oh God, I hadn't seen this yesterday. Statistical generalizability, you have a frame, you have a population, you're taking a sample, you're making some inference, and then on that basis you're making some claim through this analytic space to the domain space. Okay, so you're on the basis of the sample, you say something a bit bigger, and then you come back to the domain expert and you give him some kind of insights. Scientific generalizability combines with this other sources of information. Conservation of mass, Newton's laws. Okay, so people make generalization with different methods. The marketing manager for a company who's learned what happens in market A will have some good idea of what will happen in market B even without testing the market. So he is able to generalize not with statistical generalizability, but with first principle generalizability. There's a theory behind the generalizability. And this is a book I like very much. It's by Jay Gray, and it's a biography he wrote several biographies of Poincaré. What the emphasis, so we're talking about a very important mathematician. What he emphasized above all, he meaning Poincaré, was the act of human understanding. Preferred meaning of attaining the understanding of a problem was to find the right generalization. The right generalization. of its core concept, often in the form of an analogy. So here comes the trick. We're talking about analogies. On the left, you have a tree. On the right, you have trees. They represent the same concept. So what the analogy is doing is bringing out the conceptual value of something that is called a tree. Okay, so you can recognize a tree even if you might know the name of the tree, but you can recognize the tree. And we're talking about concepts. So we're moving to how do you generalize findings. We are not talking about concepts. There are concepts that are presented in different languages. Okay, on the right you have an algebraic formulation. On the left you have a graphical formulation of two things that have the same meaning. This is called meaning equivalence. These two representations have different meaning. They look the same, xk, xk, x squared, they look the same, but they have a different meaning. So surface similarity means they have the same, they look the same, but they have different meaning. And meaning equivalence means they might be using different representation languages, but they have the same meaning. K over x and the right curves, the same thing, the same concept. And now you can have four options. You have the options with alternative representations, different languages, the same meaning, the Q2s, and you have the Q3s where it looks the same, but it really means something different. Okay, so I'm rushing. And now if you combine the Q2s, different ways to express the same thing, and the Q1s, the main thing you want to express, you get this cloud, and at the edge of the cloud you have what is called the boundary of meaning. The things outside are outside the boundary of meaning. And now that gets me to statistical errors that Galit also mentioned yesterday. We all are familiar with type 1, type 2 errors. Now I'm going to talk about type S and type M errors. Type S errors are a directional statement. It's a sign. You're talking about the sign of the coefficient, not the coefficient, the sign of the coefficient. If I increase temperature, viscosity increases. This is my claim for reproducibility. So when I talk to the chemists, I tell them, when you increase temperature, viscosity will increase. And then the question is, am I wrong? That's what the reproducibility claim is going to be tested on. Okay, and Gelman produced this method, which is Bayesian flavored, simulation based, not analytic, not based on mathematics. You basically do a lot of simulations based on the study design to figure out the extent of the S-type error. M is for magnitude, but I won't talk about this. So if the study is underpowered, you're going to get significant type S error rates. You're showing me something? Thank you. Okay, this is work I'm doing with people in the Institute for Drug Research at the Hebrew University, and they are looking for ways to improve the diagnostics of colon cancer, especially after the colonoscopy indicated there's a problem, and they removed something, they removed the solid tumor, and did they do a complete job or not? Okay, so there are issues there because sometimes they cannot see, and they are not doing the thorough job they need to do in order for this cancer not to be stopped. Okay, so the idea is that you color these tumors, and it has to be targeted, and with some ultrasound and some microbubbles, you get this material to the site, and then with fluorescence, you can figure out if they did a good job or not. Okay, that's called luminal inspection. So I won't get into the details. This was a properly powered study. Okay, we can prove it. And here are the findings. So now I'm talking to these people and I'm asking them, please explain to me in layman's terms, as much as you can in terms that are not too technical, what it is that you claim. Okay, so after working very hard, one of the claims was increasing the charge density of this thing leads to cross-reaction with the recognition peptide, that's the name of the recognition. So they are able to present in layman's terms to some extent what their finding is. So now I'm going back and tell them, please explain it to me in a different way. The same thing. These are the key ones. And then I'm asking them, and that's really tough, explain to me something that would sound similar but has a different meaning. Okay, so what we eventually come up with is this idea that these papers should have a section called generalization, where they explain in an accessible way what is that they found, and they present a table which delineates the boundary of meaning. Okay, that's the suggestion. So InfoQ, okay. The question that we posed is really very basic. Okay, you've done some research, some applied work. You've collected data. You've done some analysis. You've visualized it. You summarized it. You communicated it. What's the quality of the information that you provided? Eventually, it's all about information, right? Information quality. Eventually, it's all about information quality. Whatever you do, it's about information quality. If nobody's doing anything, okay, I'm going back to Intel. You have these graphs, okay? If nobody's doing anything with it, I would say the information quality is poor. Nothing to do with the analysis, nothing to do, and they might not be doing something because of the lack of standardization and blah, blah, okay? There might be reasons for that. Okay, obviously, if it's not communicated properly, the information quality is poor. Okay, so we are actually looking at these dimensions, which is a language. If you want to minimize it, you can call it a checklist. I think it's more than a checklist, which asks this: for the goal of your study, is the data resolution adequate? Do you have data covering, in terms of data structure, whatever is relevant to your goal? Okay? What we saw in JAMP 13 is fantastic. The fact that you started with joint, I was really pleased. It's hidden somewhere. People don't really talk about it. I do a survey. I ask people in a group like this if they heard of ETL. How many of you have heard of ETL? Oh, much more than usual. Okay, usually maybe 0 or 1. Okay, if you ask IT people, they all raise their hands. They know what ETL is. Statisticians have not heard of that. So there is a methodology behind this. It's not just taking Excels and putting them together. Okay, and then you get into big data tables and things like that. So now there is a structure that is supported by the platform to use data, and then the text is fantastic. Now we have also the ability to use textual comments. And then the question is, how do you integrate for the analysis all this information? Okay, I was bugging Chris the other day. You're looking at the analysis of the text, but that's not really the thing that is interesting. The thing that is interesting is once you are able to combine the text with additional data to do the integration and do the clustering not on the words, but on this other data that you have. And that is mind-boggling what you can do with that. Chronology of data and goal. This is critical. Okay, if your analysis doesn't bring in the information, I mean, again, I was really impressed by the Intel presentation. People want to know what happens if you look at this product, or if you look at the data without this product. You want a response now. If the answer is given the day after, the quality of the information is poor. So the fact that you can give an answer, what you call the live, on the spot, increases the quality of the information. The same information. And we call this dimension chronology of data and goal. Okay, generalizability, I talked about operationalization, Galit mentioned construct operationalization. There is also action operationalization and communication. And we have a way to assess this. Okay, this is a suggestion. I'm sure there are going to be better ones in the future. We started with a very basic approach. Let's score the dimensions 1 to 5. And in our book, we have 3 chapters at the end which talk about how current software platforms support the InfoQ dimensions. We have a chapter with R, we have a chapter with Minitab, and we have a chapter with Jump that Ian actually worked on. And Ian made an improvement on our initial suggestion. What is nice is that we really never talked about this. This happened by itself almost, which is show some uncertainty in your score. Okay, this is Ian's contribution to the idea, and we didn't talk about this, which is really fantastic. I mean, when things happen like this, I'm really happy. I think it shows, the proof is in the pudding. You know, are people going to do this? So there is an add-on that you can get from the book's website, or I don't know where, to summarize your evaluation of the information quality presented by a certain study. So challenges. What I envisage is something that is responsive to the person who opens Jump. Someone who has done ABC should get something. Someone who has done EBF before, someone who has done nothing before, they should see different things. So there should be some personalization to the analyst. And when the analyst is doing whatever he's doing, and he has to talk to different people, there should be a way to personalize his study, his analysis, so when he's going to send some report to the VP of engineering, might be a different report than to the engineer, the process engineer in charge of the process. Okay, so maybe the dashboard will do this, maybe yes, maybe not, I don't know. But you should think of different levels of reporting in order to meet the needs of different stakeholders in the organization. Okay, it's not one shot for all. Okay, it's not black. You know, it's not the Ford car. Theory and applications, there is a serious gap. There is a really serious gap, and some people are trying to bridge the gap. I would say very few. The reason is that to bridge the gap, you have to cross to the other side, get some experience, and then move back. Okay, that's really difficult, especially in academia. You know, even statistical labs in academia are not representing real life. Okay, it's a different context. So people in academia, even if they have a lot of experience in doing consulting for their fellow peers who are publishing and they need p-values or whatever, have no idea what it is to work for a company from within, as opposed to be a consultant. There should be synergies. The idea of what I showed you for generalization is coming from work with an education psychologist, Uri Shafrir, who thought about this a lot, who developed this, and we are collaborating. And 1 + 1 is much more than 2. Conceptual understanding. Okay, we should move away from the specific numbers and try and figure out what are the qualitative implications. Okay, if we know how to do that, we will have introduced statistical thinking. And now, okay, so I have 3 more slides. And now comes something that is another big thing. We are now living in a different, I mean, people have seen this. I took it, I don't know, maybe it's copyrighted, hopefully not. It's dangerous now. You take pictures and then someone can call you and say, you made money on the basis of this picture. So Cuthbert Daniel, I also met this guy, very interesting guy, was saying you can observe a lot, by watching. We are watching things differently now. So I have 3 more slides. When we move up this quality ladder, we are living in a certain context, okay? When we start talking about information quality, we are expanding the scope. And my take on this is that if you look at the development of quality, so now I'm back to talk about quality, okay? Even though I'm a bit out of quality because we talked about this a little bit. We had product quality. Eli Whitney was the first one to introduce specifications in producing these muskets. This is all in the first chapter of Modern Industrial Statistics. And then you had Schuart, process control. Then you had Deming and Juran starting to talk about service quality, healthcare, quality in healthcare systems. These were really novel concepts. Then design quality, Taguchi, robust design, okay. And I think there is now another thing to push for, which is what we would call information quality. And where is this coming from? So I have 2 more slides. In, for example, this business of condition-based maintenance. Okay, you have a maintenance schedule. Your car, after 15,000 kilometers, is supposed to visit, to have some maintenance done, irrespective of how you've driven it. Okay, so that means something, but not really critical. In the Israeli Air Force, when they started doing condition-based maintenance, they saved lives, because some engines had to be maintained way before what the manual said. And some, they could save money and save the maintenance for later. And this was done by introducing sensors all over the system to capture what is going on, to figure out what is the optimal regimen, maintenance regimen. And you're all tracked now. If you're talking about sports, everything they do now, they talk about wearables, and they know everything that you've done. You moved your hands, they know that. In sports, wow, analytics in sport is becoming something incredible. I'm interested in this idea of manufacturing or Industry 4.0. We're talking about the 4th industrial revolution, where now, when you look at operations, there are many, many computers, one user. These computers manage the 3D printing, the sensors, the process control. Okay, so there's sensor technology going on, production technology, computing technology, and analytics. So people, statisticians, people in analytics have a key role in this development. And I'm open to some questions, if we have time.
Thank you very much, Ron. I think we may have time for just one question. If anyone? Yes, Stan. We've got, hang on a second, we've got a microphone for you. If you'll stand up, tell us who you are and where you work.
Stan Young, retired, working 24/7. When I look at your information quality thing, I start at the very bottom. If people screw up there, is there any possibility of moving forward? Where should
okay. So you have three opportunities to talk about this. Okay. You have opportunities in the design phase. What you're going to do something. Let's talk about what you plan to do. Okay, so usually we did this for research proposals of PhD students. They have to come up with some research plan. Okay, so we asked them, you're going to do this research, you're going to come up with these findings. Who are you going to present it to? How are you going to communicate the findings? Okay, and then they say, oh yeah, we should really think about this. Maybe we should talk to the people who are going to present to before we start anything and hear what, so there is some value in doing it in the planning phase. There is a value of doing this midway when you can do some correction. And the other thing that is more popular is in the retrospective study. And then they try and review things with some framework for reviewing it, which is not personal. The point with retrospective is you want to make it problem-driven, not personal-driven. Okay, so you have a way, okay, we use this data, maybe is there something else we could have done? So in a sense, you can have a discussion, and obviously the more experience you get, the discussion gets, but you can start with a very basic type of, what's the goal of the research? You're going to do something, what's the mission statement? In Six Sigma, you start with a mission statement. What is the mission statement? Let's clarify it. Because if we don't clarify this, there's no way we'll be able to judge the quality of the information. If we have not clarified the goal, you cannot say anything about the study. Maybe the graphs look good. Or maybe the analysis is sophisticated, but that's about it.
All right. Thank you.
One quick follow-up. Publishing papers, quality by inspection or quality by design?
We have reviewed I don't know, about 20 journals looking for what are the guidelines given to reviewers. Okay? The review is done by reviewers. What are the guidelines given to reviewers? We can send you this paper, but the answer is not much.
All right. Thank you very much, Ron. That's all the time we've got. Ron and Galit will be doing a meet and greet and be available for questions at lunchtime today. We also have a few of his books. Ron's kindly brought a few of his books with him to give away. There is a bowl at the registration desk. If you would like to potentially win a copy of Ron and Galit's book, if you'll drop a card in the bowl at the registration desk, we'll be doing that drawing, and you can get a signed copy of the book. And again, they will be taking questions at noon in the lobby. Now, for the rest of today, we have got another breakout immediately following this session after a brief break, but then a breakout, and then we will have lunch downstairs in the Midtown Grill, just like yesterday. So you will want to join us there for lunch. If you signed up for the Users Group Leaders Lunch, that will happen in the Valtise meeting room, which is on this end of the foyer. The Valtise meeting room for the User Group Leaders Lunch, if you signed up for that. And then after lunch, we've got 2 breakouts before lunch, and then 1 breakout after lunch. So 2 breakouts before lunch, and 1 more breakout. And then we will be back in here for the final plenary with Pedro Saraiva at 2:30 this afternoon. At lunch, if you want to have some guided conversations with people in a similar interest, here are the discussion topics for today. These are different topics from yesterday. Just like yesterday, though, sit down, introduce yourself, and have a conversation. Pick your topic, and you will find those in the Midtown Grill downstairs. With that, I want to invite you to take your break and then pick your breakout, and I will see you back at 2:30. Thank you so much.